Now let's take a look at an example where we have objects colliding and joining after a collision. So thinking about that, our original equation is the momentum of the first object plus the momentum of the second object before is equal to the momentum of the first object plus the momentum of the second object after. So remember, we put those primes in for the afters. Well, thinking about that, that means the mass of the first object times the velocity of the first object plus the mass of the second object times the velocity of the second object is equal to the mass of the first object after times the velocity of the first object after plus the mass of the second object after times the velocity of the second object after. But as in example number 8, which is what we're going to take a look at next, it says two objects collide and join after the collision. So we go from two objects down to one object. And they're going to have the same velocity, but what's going to happen to their mass? We're just going to have to add their masses together. So we have m1v1 plus m2v2 is equal to the mass of the first object plus the mass of the second object prime times the velocity of the object. We're just going to call it a 2, make things easy. All right, so number 8 says two objects collide and join after the collision. Before the collision, the first object, so the mass of the first object is 178 kilograms, was traveling at 14.9 meters per second north, while the second object, 695 kilograms, was traveling at 19.5 meters per second north. What is the velocity of both objects after the collision? So the velocity after the collision is what we're looking at, because remember, they're joining together. So real quickly, let's hammer out our momentum before. So the momentum of the first object is P1 equals M1 times V1. So we get mass is 178 times the first velocity, 14.9. We get the momentum of the first object being 52.2 kilogram meters per second. Then we have the momentum of the second object, P2 is equal to M2V2. So we get mass 2, 695 times the velocity of 19.5, and we get momentum of object 2 as 13552.5. So we have our initial momentum. So we're going to take those guys and add them together, because remember, our equation is P1 plus P2 is equal to P1 prime plus P2 prime. So we have 2652.2 plus 13552.5, and that's going to be equal to the mass times the velocity of the second object. Now remember, they collide after and they stick together. So what's going to happen to those masses? Those masses are going to add together. So our mass of our mass after the collision is actually going to be 178 plus 695. So 178 plus 695 gives us 873 times the velocity of that object after the equation. We don't know what that, or after the collision, and we don't know what that is. So the beautiful thing about this is that the problem actually gets a little bit easier. So we have 2652.2 plus 13552.5, and we get 16204.7, and that is equal to 873 times v squared, which is our x. Divide both sides by 873. That's odd that those numbers are the exact same as the last example. And we get 18.56 meters per second. So the velocity after the collision of the two objects, because remember, they're stuck together, so there's only one velocity, 18.56, which is letter choice B. B stands for because you're very smart.